Your proxy server works perfectly until you need to tweak how it connects to the backend for every single request. You'll see how to take full control of session creation by implementing a custom client factory, giving you the power to configure each backend connection exactly when and how you need it.
Hash custom factory with specific configuration. Def custom client factory. Client proxy client backend server, Pi. Hash add any custom configuration here. Return client. Proxy equals FastMCP proxy. Client factory equals custom client factory.
This demonstrates the factory pattern combined with proxy delegation, creating a controlled gateway to backend services. The code establishes a client factory that generates dedicated proxy clients on demand, rather than sharing a single connection. What makes this distinctive is the separation between session creation and usage, enabling precise control over resource isolation and lifecycle. The pattern works by deferring client instantiation to a factory function, which acts as a session provider. Each request receives a fresh client instance by default, ensuring clean separation between operations while maintaining the illusion of a single endpoint. This design principle follows the dependency inversion pattern, where the proxy server depends on an abstraction, the factory, rather than concrete client instances. This approach solves the classic problem of session management in proxy systems, balancing isolation with performance. You'd use this when you need to expose backend services safely across multiple clients, particularly in concurrent environments where shared state could cause conflicts. The trade-off is slightly higher overhead per request, but the benefit is complete elimination of session collision risks and the ability to customize each client's configuration dynamically. Let's break it down line by line.
Hash custom factory with specific configuration. Def custom client factory.
This defines a factory function for custom client instantiation. The factory pattern centralizes client creation, enabling consistent configuration and easy modifications across the application. Here it prepares a specialized proxy client for the FastMCP proxy to use.
Client proxy client backend server, Pi.
Instantiates a proxy client targeting the backend server. This is the concrete client implementation that handles all communication with the server, abstracting connection details and protocol handling.
Hash add any custom configuration here. Return client.
This placeholder marks the extension point for client customization. You'd add middleware, timeouts, or authentication here before returning the configured client instance. The pattern enables centralized configuration while keeping the factory interface clean.
Proxy equals FastMCP proxy. Client factory equals custom client factory.
This instantiates FastMCP proxy with a custom client factory, enabling dependency injection for the proxy's backend connection. The factory pattern here centralizes client configuration, making it reusable and testable across the application. All proxy instances will now use this standardized client setup. Session management pattern. The client factory approach in FastMCP 2 gives you explicit control over backend session lifecycle, replacing the deprecated direct client parameter for better isolation and concurrency handling. A shared session factory will cause context mixing between concurrent requests, while fresh sessions per request prevent this at the cost of higher overhead. This pattern forces you to consciously choose your session strategy rather than relying on implicit behavior.
The proxy that shares everything knows nothing, while the proxy that knows nothing shares everything.